Hey guys, so let's go ahead and take the lesson 3 notes in our books on page 47, and then you'll work on the two IXL skills that have been assigned for your independent work this week. I decided to reduce the skills, like give 2 instead of 3 this week, just because IXL has been kind of a lot for people lately, and I just wanted to reduce it a little bit. Um, so go ahead and grab your workbook if you don't have it already. I'll share my screen so you can see mine. Let's see here. Oh, I'm all out of whack here. Let's see. There we go. That ought to work. All right. So right now we're learning about proportional relationships. There's this special number, the constant of proportionality, that is a big topic of everything that we're talking about. Is a big piece of what we're doing. I'm not sure if I've mentioned this in class yet. In the My Notes section, let's make a really important note about the constant of proportionality. The constant of proportionality is always abbreviated or represented, maybe it would have been a better word, but whatever, as the letter K. You might think, well, why isn't it C, right? C for constant. Well, C already has like a lot of special uses in math. Most specifically, like if you think about that Albert Einstein theory of relativity equation that people talk about all the time, that E equals mc squared. The C in that case stands for the speed of light. And the speed of light is used in a lot of equations. And so it's always the letter C. And so if we can avoid using the letter C for other important things, we do. So we give the constant K. So just be aware of that. If I say K in conversation or I write K on the screen, I'm talking about constant of proportionality. So in this case, what is a constant of proportionality? K. Well, K is a special K? No? All right, whatever. Is a special number. I don't know why I wrote number, right? So that already feels weird. K is a letter, it's not a number. Okay, well, K is a letter, but it represents a special number that is the, I'm going to say, constant ratio. So constant in math just means never changing. It's the opposite of a variable. Variable can change. Variable, to vary means to change. Variable. Constant, on the other hand, means it just stays the same, doesn't change. K is a special number that is the constant ratio between two quantities. And just for simplicity's sake, oh geez, I didn't realize those partially off the screen, sorry. For simplicity's sake, let's just say the quantities are X and Y. You're like, Mr. Thomas, this isn't simple. I got a K and an X and a Y. Like, nah, this isn't simple. I know, but like, there's not really any other good way to talk about this stuff. Just think of X as like down here. We're going to do an example about apple juice later, and the volume, the ounces, will be the X quantities, and the amount of sugar in each one of those ounces will be the Y quantity. So that's what I mean. Like, X could be sugar and Y is flour or whatever, right? I'm just using these letters because it shortens things when you're trying to talk about this stuff. All right, so the constant ratio between two quantities, X and Y. You can take any X value. So X is like a general term for all the different volume numbers here, but a particular X value would be like 32 as an X value or 12 as an X value. So you could take any one particular X value, multiply by k and get the y value. Or take any y value, divide by k, and get the x value. Oh, that was a lot, right? If we were in class, I would like stop, take a time out, let you catch up to keep writing. But since it's a video, you can just pause, right? No big deal. So yeah, k is a special number. If you know the x values, you can multiply by k to get the y values. And if you know the y values, you can divide by k to get the x values. And the other special thing about it is it's constant. As you're moving through a table like this, that k number has to stay the same in every single row. If it ever changes, then you do not have a proportional relationship, or maybe messed up on some math somewhere. I don't know, who knows? All right, so when I'm looking at a table like this, and I want to fill in some missing values, like all these y values that are missing, I'm thinking, okay, let me establish what my k is, my constant of proportionality, and then I can just start using it. I can just start multiplying x values by it, or dividing y values by it. It's not too bad from there. There's like a formula for getting k. Let's put that in the My Notes section underneath the screen stuff here. I'm just going to write it in big old letters. K equals y over x. Please make sure that you write y over x there, y over x. It's the biggest mistake that students make every year at the beginning of the year when they're learning this stuff, is they write this as x over y, or they forget later and they start doing x over y instead, because x divided by y feels more natural, right? X comes before y, so x should be on top. No, 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 no. Y over x. And the reason for that is because we're trying to find a number that when we multiply it by an x value, we get the y value. That's how the constant of proportionality is defined. It's the number that if you multiply it by an x value, you get a y value. And so you work in reverse of that to find the number. You say, okay, well, if I need a number that when multiplied by x gets me y, then let me do y divided by x to get that, right? Working in reverse of multiplication with division. So in this case, I need to take this y value that I have here, 26, divide it by its associated x value, 8. That's going to get me my k. So let's hear. I'm going to use green over here because I got a lot of purple over here, so I'm going to use green. K equals y divided by x, which in this case is 26 divided by 8. So I could punch this into a calculator if you want to, go ahead. I'm just going to talk my way through it though. If I count by 8s, 8, 16, 24. Okay, I'm almost at 26 now, right? I have 2 left over because I'm at 24. So this is 24, or sorry, no, I counted 8 3 times. So this is 3 with 2 8s left over. And 2 8s is the same as a fourth. But I don't know, I feel like doing decimal math right now. So I'm going to write it as 3.25. That's my k. This is my special number here, 3.25. Now all I have to do is multiply every single one of these numbers by 3.25, and I've got the correct y value. So 8 times 3.25, 12 times 3.25, 32 times 3.25, and 128 times 3.25. Sometimes you will hear the constant of proportionality referred to as the unit rate. This is something else we should put in the My Notes section. I'm going to write it in purple underneath the formula here in orange. K is the same thing as unit rate and scale factor. All 3 of these things are essentially the same thing, right? Scale factor was that number you took, you have this one shape, you multiply all the sides by this one number and you get the new shape. K is the same thing. You have this like one list of numbers, you multiply all those numbers by this K, the special K. and you get all your new numbers. Well, the unit rate's a little different, but it still winds up being the same thing. The unit rate in math, well, unit meaning one, right? So unit rate is how much do you get of this one thing for every one of the other? How many, carrots, pounds of carrots can you buy for $1? Or how many of this thing come in every one box, right? Well, this K winds up being the exact same as the unit rate, because what this 3.25 is saying is that for every 1 ounce of apple juice, there's 3.25 grams of sugar, right? Because if I put a 1 in the X column here, and then I wanted to figure out the Y, I would multiply by 3.25, and the answer over here would be 3.25. So for every 1 ounce, I'm getting 3.25 grams of sugar, which is exactly like the definition of a unit rate. How much are you getting per 1? So if I give you like some IXL work and it says unit rate instead of proportionality or whatever, it's just because they decided to use the word unit rate instead of constant proportionality. They mean the same thing. All right, so let's fill in this table. 12 times 3.25. It's kind of late in the evening, you guys, right now. I'm gonna go the lazy route. All right, don't judge. 12 times 3.25, 39. All right, so if you got 12 ounces of apple juice, you got 39 grams of sugar. That's a lot. All right, so 32 ounces of apple juice times our K, 3.25. You're gonna have 104 grams of sugar. And last but not least, 128 times 3.25. If you got a 128 ounce thing of apple juice, that's a big old thing of apple juice. That's like the biggest one you see at the store, or maybe even like the Costco size one or whatever. You're gonna have 416 grams of sugar. That's a lot. That's like half a pound of sugar. That's like, I think the little bag you can buy in the store is like a pound, so like half of that bag. Okay. So what is the constant of proportionality in this relationship? Well, we're going to call it K. So we're going to say K equals 3.25. And it says, what does it tell us about the situation? Well, let's write that sort of like unit rate-ish sounding answer. For every ounce of apple juice, there is 3.25 grams of sugar. All right, we're not quite done yet. Go do your IXL skills in a minute. There's one thing I want to do though, because this example isn't very good, because notice all of the values that were missing in the table were in the Y column. They were all sugar. What if it had been the other way around? What if they gave us the amount of sugar and we had to figure out the ounces? You would divide instead of multiply. But I just want to get a little example of that down here in our notes, so we've done it. So we can, yeah. So I'm just going to make up like another random table, right? Let's say, go ahead and just draw this table down here. It doesn't have to be all perfect or anything. We're only going to put a couple values in there, so don't worry about it having to be all humongous or anything. Let's see here. How about, let's say we're doing cookies. And over here will be flour, but we'll call these our X values. And over here will be sugar, and we'll call these our Y values. All right, and let's just put like 3 rows on here. Okay, so maybe for like every, I don't know, when I'm making a batch of chocolate chip cookies, I think I use like maybe 3 cups of flour and like 2 cups of sugar. I think that's kind of normal. All right, so pretty simple ratio, 3 to 2, right? Well, what if I wanted to make a big old batch that contained maybe like 10 cups of sugar, or maybe even like a Mondo batch that contained like 20 cups of sugar. All right, well, first, let's figure out our constant of proportionality. In this case, K is going to equal a Y value divided by an X value. That never changes. It's always Y divided by X. And so that'll be 2 divided by 3, which is 2/3. I'm just going to make my life easy and just keep it as 2/3. I don't want to write this as a decimal, because that'll be 0.666666666 going on forever, repeating. It's ugly. All right. And so now, see, in the previous example, we were taking all the X values and multiplying by our K. If you have your Y value and you need your X value, you have to work in reverse now. You got to divide. So in order to figure out this second box here, I need to do 10 divided by 2/3. And that gets a little sketch, right? Well, this is where keep, change, flip is going to come into play. This is why we were practicing this a little while ago. I'm going to keep that 10 the same. Well, I'm going to write it as 10/1 though. I'm going to change the multiplication, and then I'm going to flip that 2/3. So this becomes 10/1 times 3/2, which is 30/2. Oh, I'm getting too close to my green writing over there. It's getting ugly now. And 30 divided by 2 is 15. And I know there's easier ways to do this, right? You could have looked at it and just said, oh, well, 2 times 5 is 10, and 3 times 5 gets you 15. You would have got the same answer. But you need to be really good at finding this K and using it, because it's going to be connected to some equation stuff that we have to solve later. So I know there's other ways to solve it. Please try to get good at this way as well. All right, and so let's do this last row. I'm going to do the same thing. I'm going to take that 20 and I'm going to divide it by 2/3. I'm going to use a different color just so it's easier to see from the other stuff. 20, I'll write it as 20/1, divided by 2/3. Well, if I keep, change, flip, that's 20/1 times 3/2, which is 60/2, which equals 30. And yeah, there was probably an easier way to get that. You could have just seen that, oh, 10 doubled to 20, so 15 doubles to 30. But I need you to be able to do it this way, especially when some more complicated examples come up where it's not as easy to figure it out the old-fashioned way. You might have to do it this way. All right. Please do the 2 IXL skills that I've assigned as well. Remember, no more than 15 minutes per skill. But if you finish one skill in like 2 minutes, then maybe you could do more than 15 minutes in the other skill if you need it, right? Like 30 minutes total, basically, we can call it that. All right, see you guys.